Okay, sir.
Okay. So you know that, okay. So we know that current is nothing but moving electrons or protons. I don't know the name proton is correct or not. Let's say that plus ion. Okay. Okay. So in anyway, so you know that if electrons or protons or plus ions are there, okay, it will create a E field, no? Okay, it will create a E field, electric field. Okay, it will create the electric field. That is, you know. Okay, and also if these are moving, this plus and minus, um, I can't remember the name. What is that? R open. Let's find it. Iron. Doesn't give the word, no? What is that? I can't remember. Yeah, yeah, maybe charge. Okay. 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 Thank you. Okay. Yeah. Okay. Thank you, Geet. Okay. Okay. So I think it is the correct word, no charge. Okay. So you know that uh, if the plus or minus charge is there, plus or minus charge is there, okay, it will create a E field. No, it will create a E field, electric field. Okay. It is a electric field. Electric field. Okay. And you already know that if these are moving, if this uh, plus or minus ion charge are moving, okay, it also create a magnetic field, no, H field. So this is the magnetic field. Okay. So you know that if there is a current flowing through a conductor, okay, that current will create an electric field and also a magnetic field. Okay. So that current, okay, if the current is there in the conductor, it will create in some place electric field or and magnetic field, electric field and magnetic field. Okay. So we'll call it electromagnetic field. Electromagnetic field. Okay. Electromagnetic field. And if this electromagnetic field is radiating or changing, okay, E field and H field is changing in the space, okay, not in the time, okay, in the space, we called it a wave, okay, we called it a wave, okay. So you know that if there is a current flowing through a conductor, it will create an electric and magnetic field at some point, so that it will create an electromagnetic field, okay, and that electromagnetic field is changing with respect to the space, okay, we called it electromagnetic wave, okay. So I think you already have that knowledge, okay. Okay, now let's say that we have antenna here, okay, let's say that we have antenna here, okay, and so we feed a signal to this antenna, okay, we feed the signal to this antenna, okay. So this antenna has a certain current, okay, certain current, okay, certain current. Actually, we called it current density. Okay, I will tell you later. Okay, so we have a certain current. Okay, so that current may be depend on the shape of this antenna. Still, we don't know. Okay, now let's say that there is antenna. Okay, and we feed the signal to antenna. Okay, so that antenna has a current. Okay, so it creates the electromagnetic field. Okay, say now you need to find the electromagnetic field at some point. Okay, so here you need to find the electric field and you need to find the magnetic field here. Okay, so for that you know that okay, you can see that you are doing this calculation in the space, no? In a space. මොකක් හරි අවකාශයක තමයි අපි මේ calculation කරන්නේ. Okay? It may be our real environment. Okay? It may be the real environment. Okay? Or it may be any hypothesis environment. We don't know. Okay? But anyway, we have to do this in a space, no? Okay? Okay. Now you can see that this location. Here it is a location. We can see that, we can say that this is a location. Okay. This is a location. Okay. And this location we define may be related to this point. Okay. So this will be our reference point. Okay. This will be our reference point. Okay. So if we want to find the E field and magnetic field and other many parameters, we have to do that calculation with respect to some location. Okay, so what should we need for that? අපිට මොනවද ඕන එක ගන්න මොන වගේ tool එකක්ද ඕන? Okay, so I think you already heard that we have to use some coordinate system, no? We have to use a coordinate system. We have to use the coordinate systems. Okay, so what are the coordinate system you have learned? Can anyone tell me? What are the coordinate system you have learned? Can anyone tell me, please? Actually, we need this coordinate system because we need to analyze or we need to find this parameter with respect to a space, no? Okay. Okay. So we have to define some location. To define a location, we have to use a reference point. Okay. For that, we have to use a coordinate system. Okay. If we use the coordinate system, we can get rid of these problems, no? Okay. So can anyone tell me what are the coordinate system we have learned? I think you should, in your mathematics, you should have learned 3 types of coordinate system. What are they? I think in O-level also we are using one type of coordinate system. Okay. As I can remember, A-level also use the same coordinate system. But when you come to the, but as an engineering undergraduate, you should have learned other coordinate system also. What are they? Can anyone tell me?
Polar coordinates.
Yeah, very good. One is a polar coordinate. What are they?
Linear, sir.
Yeah, linear. I think you are talking about Cartesian coordinate, no? That is Cartesian coordinate. We also called rectangular coordinate. Rectangular coordinate system. Coordinate. Okay. And polar coordinate. I think we can say that this is a spherical coordinate. Have you learned these things? I think you should have learned. Spherical coordinates, and what is the other one? I think now you can remember maybe. Spherical, then cylindrical coordinate. Coordinate system. Okay. So I think in your engineering mathematics, you have learned these 3 type of coordinate systems. Okay. Am I right? ඔකට මේක ඉගෙනගෙන තියෙනව නේද? මේවා ඉගෙනගෙන තියෙනව නේද? Can anyone tell me? Can anyone feedback, please? Have you learned these things? මේ rectangular coordinate, spherical coordinate, cylindrical coordinate ගැන ඔකට ඉගෙනගෙන තියෙනව නේද? Yes, thank you. You have learned, no? Okay, okay. Maybe you don't remember, okay? You can't remember, but anyway, I will. We will have a recap, okay? But if you have learned this thing, it will be okay, okay? Because we just have a recap, okay? I think that recap will enough, okay? But I think using this coordinate system, you have also solved some question also in mathematics, in your mathematics, okay? So I think now you have, if I give a recap, I think it will be okay for you, okay? Okay, so we will have this, we will have a quick recap of this rectangular coordinate, okay? And also, okay, and also, you already know that this electric field, magnetic field, what are they? Are they vector or scalar? Are they vector or scalar? This E field and magnetic field, are they vector or scalar? Can anyone tell me? They are vectors, no? Because it has, electric field has a magnitude as well as a direction. And also this magnetic field also has a direction as well as magnitude, okay? So it has both magnitude and direction, so it is a vector, okay? So sometimes we need to, so I think you have learned about vectors also, no? Some vector identities, I think you already have learned in your mathematics, okay? So maybe you can remember when we are using these things, you maybe you can remember those things, okay? Actually, that is why we are learning engineering mathematics, okay? We are learning these things. Sometimes we have to apply them to solve some engineering problems, okay? So here, now actually we are going to apply our mathematics knowledge to solve some complex engineering problems, okay? Okay, so we need some vector identities, okay? So what I want to tell you is that you need to refresh your memory on this, okay? So I think still you have your maths note maybe, okay? Please go through it and try to refresh your memory on these, okay? Vectors and these coordinate systems, okay? And also you can see that sometimes, so this antenna, okay? So normally antenna is in a 3-dimension space, no? It is in a 3-dimension space, okay? So sometimes we have to find some parameters related with the 3-dimension and with 2-dimension also. Okay. For that one also, you need to know about, I think you have learned about surface integral. Surface integral. I think these are not much complex. Okay. Surface integrals and volume integrals. Okay. Okay. So I will give you a recap. Okay. I will give you a recap. Don't worry. Okay. But anyway, what I want to tell you is that please go through your mathematics notes also and see the chapters related with vectors, related with coordinate systems, and related with these surface and volume integrals topics. Okay. Please go through that and please thorough with them. Okay. Okay. So first we will see the coordinate system. First we will see the coordinate system. Okay. Coordinate system. Okay. So the first one is the rectangular coordinate. Okay. So you know that we have x, y, z. Okay. So if this is z and this is y, okay, and this is x, x is this way. Okay. Can you remember how this direction we get? How this x, y, z direction we get? You can't write it as you like. Okay. You can't say that this is x and this is y, this is z. Likewise, you can't define. Okay. It has a specific way to define this direction: x direction, z direction, and y direction. Okay. Can you remember that? Okay. And this is the middle point. Okay. So it is called 0 point. Okay. Actually, that is the reference point. Okay. And this side is minus x direction. This is minus y direction. And this is minus z direction. So this is y direction. This is x direction. And this is z direction. Okay. And if you consider this direction, it is minus x. And if you consider this direction, it is minus y. And if you consider this direction, it is minus z. Okay. Can you remember? Can you remember how this direction we get? Using what? Can someone remember? Actually, we use a rule. We use a rule to get this direction. What is that rule name? It is right hand rule, no? It is right hand rule. Okay, I can't remember the name correctly. I think that is the name. Okay, it is a right hand rule. Okay. Okay, so I can't write the hand here. Okay. Let me check. Okay. Can you see me? Okay. So you have to use your right hand. Okay. You have to use your right hand. Okay. Okay. this is my right hand, okay? This is my right hand, and you have to you use that one, okay? And these three fingers, using these three fingers, you can define, okay? And this is X direction, and this is Y, and this is Z. X, Y, Z, okay? If you point this way, this is X, this is Y, this is Z. First finger is X, second finger is Y, okay? You use these three fingers, okay? You use these three fingers, okay? So this is the first finger, it is X, and this is Y, second finger, okay? This is my right hand, okay? And this is the third finger, okay? And it is Z, okay? So you have to keep those direction perpendicular to each other, okay? So these directions are perpendicular. These directions are perpendicular. This Z is perpendicular to X, and X is perpendicular to Y, and Y also perpendicular to Z again. Okay, so you can make your finger in this way. So all are perpendicular to each other. Okay. Okay. So this will be your X direction, and this will be your Y direction, and this will be your Z direction. Okay. So you can see that I have defined it in this way. Okay, in this way, because X is into my body. Okay, in my body direction. Okay, so sorry, X this one. Okay, in this way, X Y Z. Sorry, Z is this direction. Okay, X is toward me. Okay, and Z is upright. Okay, and X is in this way. Okay, so can you imagine this one? Okay, so this is X. Okay, so it is toward me. Okay, and this Z is toward up. Okay, toward the roof. And this, the Y is this direction. Okay, if you put like this, okay, so this is X and this is Z. Okay, so X is, can you see mine? So this is X. Okay, so you can see here in the diagram, X is to our side, no, toward us. Okay, and Z is up. Okay, and Y is this direction. Okay, so you can use this way also. So X will be this way, X will be this way, Y is this way, and Z is this way. Okay, so if I write X, if I point X direction this way, okay, X direction this way, so this is X, that is this way. Okay, and Y direction, this is Y direction, it is inside the paper. Okay, it is not our direction. Okay, so it is inside the direction, so this will be Y. Okay, so this is X and this is Y. Okay, so that is perpendicular to this sheet. Okay, it is inside the sheet. Okay, so X, Y, and what is the Z direction? Can anyone tell me what is the Z direction? Use your hand and tell me. Z direction is up or down? Is this way or this way? This is up and this is down. Can anyone tell me, is it the up or down? Please tell me. Yeah, your answer is correct. Please, I want 1 or 2 answer. It will be okay. If it is wrong, it will be okay. Okay, but give me another Answer, please. What about others? Yeah. Yeah. One more answer. Both answers are correct. So can you see me? I can't see me. Ah, okay. No, okay. So you can see that. Okay. You can see that this is X. Okay. So get your hand. Okay. Get your hand. And this is X direction. This is Y direction. This is Z direction. Now, which way X? X in this way, no? This way. Okay. Okay. And this is Y. Y is inside the paper. And Z is this. Okay. So your finger, this finger is pointed to down. Okay. So down is the Z direction. Okay. So the Z direction is this. Okay. Okay. So in that way you can define the direction. Okay. So you can't select the direction as you wish. Okay. But you can select. But according to this uh, right hand rule. Okay. So according to the right hand rule, you can define a X direction in any way. Okay. I will turn off my camera. Okay. So you can, if you want, you can define a X direction anyway. You can define the X direction this way, this way, this way, this way, this way, or inside the paper or outside the paper. Anyway, you can define X direction. Okay. But if you define the X direction that way, okay, and other directions should uh, obey to this right hand rule. Okay. So you can define any direction, but those directions should be obeyed to this right hand rule. Okay. So that is the idea. Okay. Now we will quickly see the X, Y, Z coordinate. Okay. So this is the reference point. Okay. And I uh, define any, so this is a 3 space. Okay. So you can see that this is a 3 space. Okay. So in that 3 space, I define any point. Okay. I define any point and I called it R. Okay. And I called it R. Okay. And so this is a point. Okay. And so if I join this reference point and this R point together using a line, okay. So this is my R point, okay. And I use, so this is my reference point, 0. And I connect this reference point with this R point using a line, okay. Okay. And this direction I define as the direction of R, okay, as direction of R, okay. So this direction is the direction of R, okay, I define it, okay. And from here to here, it has a magnitude, no? Okay, from here to here, it has a magnitude, okay. So magnitude is equal to this distance, okay. The magnitude is equal to this distance. I just image like that, okay. So I define a R point, okay. I define a direction, okay. So direction is this way, okay. And I define a magnitude also. Magnitude is equal to the distance from here to here, okay. So I have designed this R, a direction and a magnitude. Now what is this R? R is a vector, okay. And we called it position vector, okay. So what is a position vector? What is a position vector? Okay, any vector, okay, any vector, a vector, arbitrary vector, okay, that should indicate the location. So it indicates the location, okay, or position, okay, position of a given point with respect to this point, okay, with respect to this point, okay. So this is a reference point. It can be arbitrary point, okay. It is a reference point, okay. So that is the position vector, no? A vector that define a location with respect to any arbitrary position. That is the position vector, okay. So if I write it, position vector is a vector, okay, position vector is a vector that define or indicate, I think the word is indicate, a location or a position, okay, or a position with respect to any arbitrary reference point, Arbitrary means it can be changed, okay. It can be changed. You can define this position with respect to any point, okay, any arbitrary point. But normally we use this origin. This is called origin actually, okay. Normally we used origin, okay. So I think you clear this one, okay. And I think if you can remember that we have defined this R like this R, we have defined this R x dash plus y dash plus z dash. Can you remember this? Okay, so this is a position vector, okay. And what is this x, y, z? This is the x, y, z value, value, okay. So if I write this, okay, so there is a value with respect to this x also, okay, because this is 3 dimension, okay. Is that clear? Okay, I will write this, okay. So you have y, x, z, okay, and this is your position R, okay, and it is like this, okay. So this is the R, okay, and this is x and this is y, and it is also we have a x value also. So this is the x value, and this is the y value, and this is the z value up to this, okay, okay, this, okay, and this x is this value from here to here, okay. Y is this value from here to here, this value, and z is this z axis value, Okay, so these are the value x, y, z. Okay, and what is this? Can you remember what is this? Actually, these we called unit vectors. Can you remember that? We call this unit vectors. Okay, so this is the unit vectors for x direction. This is the unit vector for y direction. This is the unit vector for z direction. So this is x direction unit vector. This is y direction unit vector. And this is z direction unit vector. Okay. So these are unit vectors. Okay. Unit vector means actually x bar. Okay. So you have any x direction vector. Okay. And if you divide that vector with the magnitude of that vector, you will get the unit vector. Okay, so this unit vector has a direction and magnitude. The magnitude is unity. Okay, because you are divide it with the magnitude. Okay, so this has a unit magnitude and direction. Okay, so that is why it is called a unit vector. Okay, so some of you guys couldn't completely understand this. Okay, so if you can't understand this, okay, I recommend you to refer your maths books again. Okay, at least try to remember these things. Okay, sometime later you could understand these things. Okay, when we are carrying out. Okay, you you can understand these things. Okay, but it is better if you can refer your maths note and refresh this memory. Okay, so this is nothing but unit vectors with different with respect to some specific direction. Okay, so this is x direction unit vector, this is y direction unit vector, and this is z direction unit vector. Okay, so likewise you can using this coordinate you can specify any location. Okay, so that is rectangular coordinate system. Okay, but when we are learning about antenna, sometimes we have to use the rectangular coordinate sometime, and also sometimes we have to use spherical coordinate also. Spherical coordinate. Okay, can anyone tell me how this coordinate system get the name rectangle? Why we called it rectangle coordinate system? Why this we called rectangle coordinate system? Okay, can anyone tell? Rectangle එකක් කියන්නේ හතරස් පෙට්ටියක් නේ. Rectangle means that is a solid item. Okay, that is a box. Okay, that is a rectangle, no? Okay, so why we called it rectangle? Okay, let's say I can't find a rectangle here. Okay, okay, let's say that this is a rectangle. Okay, this is a rectangle box. Okay, but this is not really a rectangle. Okay, and you can see that. Okay, this is Z direction. Okay, so this may be the Z direction. This may be the x direction and this may be the y direction. Okay. And your R is here. Okay. So you can see that your R is, your position is placed in a rectangle, no? So you have a box like this. Okay. You have a box like this. Like this. Okay. So this kind of box you have. Okay. So you define, so here maybe your x, sorry, z direction. Okay. And this may be your y direction and this may be your z direction. Okay. And so your point is here. Okay. Your point is maybe here. So you can see that your point is in a rectangle. No, your point is in a rectangle. Okay. So that is why we called it rectangular coordinate system. We defined that location with respect to the rectangle. Okay. Then what is spherical coordinate? Okay. What is spherical coordinate? Spherical coordinate means we use the sphere. No, that is a ball. No. Here I can't find a ball also. Okay. Okay, anyway, okay. So you have a ball like this. Okay, you have a ball like this. This is a circle, no? Okay. Ball means this should be a 3-dimension, no, like this. Okay. So this is a ball. Okay, like this. Okay. And you define a, look, in a this position vector, you define a location in this ball. Okay. Inside on this surface of this ball. Okay. And using this ball, you are going to tell the location of this point. Okay. Let's say that this is the R point. Okay. And you are going to give the location with respect to the with respect of some parameters of this sphere. Okay, of this ball. Okay. Okay. So if you have origin, okay, so that is the center of this ball. Okay. Let's assume that this origin, so that is a reference point. Okay. So that is the center of this ball. Okay. And you can define one what is called one measurement. You can define one measurement using this center. Okay. Using this center and the position of this point. Okay. And if you join these two together, so this will be the radius of the sphere. Okay. So that will be the radius. Okay. And the radius direction is this way. Okay. So this is the radius direction. Okay. Okay. So this is the direction. Okay. Radius direction. But it is not enough because this is a 3-dimension point. Okay. And you should have at least 3 reference to give this location. Okay. If it is in a 2-dimension phase, it is enough to have 2 measurement from a reference point. But this is 3-dimension. Now you need at least 3 measurement. Okay. So 1 measurement I get using the center. Okay. And other measurement I get using the direction. Okay. So you know that this sphere have this way, no? Like this. Okay. So this, so you have like this. Okay. And this. Okay. So this is another plane. Okay. Inside. Okay. Let's say that this is the ball. Okay. So here your point is here, and you get one measurement from the center of the ball. Okay, from the center of the ball. Now you cut this ball in this way. Okay. Now you have a half ball like this. Okay. You have a ball like this. Okay. You have a ball like this. Now you have cut this like this. Then you have this circle. Okay. You have this circle. Okay. Now I draw this circle. Okay. This circle. So this is a half ball. Okay. This is a half ball. If I get this is a half ball. Okay. So that plane you can define a direction. Okay. So direction I get this direction. Okay. So that is I called theta. Okay. And you have a ball like this. You cut it in this plane. This plane. Okay. So you have a ball like this. Okay. You have cut this plane. So I have this half cycle. Half ball. Okay. And here we have a cycle. Okay. So that is this. Okay. That is this way down. Okay. So, and also I can define that location also, that direction also. So that is also angle. Okay. So I define it as 5. Okay. So using this r, theta, and 5, you can define this location. Okay. Could you understand that one? ඔකට ඒක තේරෙනවද මම කියන එක? So I have write this x, y, z. Sorry, this is z, and this is x, and this is y. Okay. Now I draw a ball like this. Okay. I draw a ball like this and like this. Okay. Okay. Now I want to define a position here. Okay. So this is the origin of the ball. Okay. So I get it as r. Okay. It is as r. Okay. So this is the unit vector direction for r. Okay. Unit vector direction for r. Okay. And you can see that you have a plane in this way. Okay. This xy plane. Okay. That is this xy plane. Okay. So I have a location. No. Okay. So I come to this plane and I measure this angle. Okay. I measure this angle from here to here. Okay. From here to here, like this. Okay. And I called it theta. Okay. So this angle, I called it theta. Okay. Okay. Sorry, not theta. Sorry. This is 5. Okay. I think I interchange. Okay. So this will be the 5 angle. Okay. And I have this ZY plane also. Okay. So if I define the angle in that plane into this direction, from Z direction, okay, from this Z axis, okay. So let's say that it is theta. Okay. So you can see that using this r, theta, 5, okay, I can define this location. So this is r, theta, 5. This location is r, theta, 5. Okay. This location is x, y, z. Okay. This location is x, y, z. Okay. And this location is r, theta, 5. Okay. Okay. So, can anyone tell me how we can write this position vector? How we can write this position vector? Can anyone tell me? ඔකටට හිතන්න පුළුවන්ද අපිට මේ position vector එක කොහොමද ලියන්න ඕනේ කියලා? To write this position vector, you have to define a magnitude. You have to define the magnitude, and also you have to define a direction. Okay, you have to define a direction. Okay, have you any work? Okay, can we do our discussion up to 5:30? Is that okay? Can we do our discussion up to 5:30? So I will do it. Okay, so if you have any work, you can leave. Okay, but I will continue this up to 5:30 and I will upload the session. Okay, so you can refer this after. Okay, but you need to understand these things. That is the important thing. Okay, you need to understand these things, and if you have any problem, you can ask me. Okay, okay, I will continue. Okay, so if you have another work, plan work, because I request you to allocate only 1 hour from 4 to 5. Okay, so if you don't care, I will continue this. Okay, because at least we need to complete this coordinate system. We need to recap. Okay, but we need to understand it, this one. That is the most important thing. Okay, so that we can apply them. Okay, if you can't understand the concept, okay, you can't apply them correctly. Okay, okay, so tell me, some of you can tell me, how can we define this position like that? The only requirement is you should define a magnitude and you should define a direction. Okay, so how can we define? So in this rectangular coordinate system, you have to use this one, because here the position. Okay, so it is not in x direction, it is not in y direction, it is not in z direction. You have to define the direction. Okay, and also you have to define the magnitude. Okay, so here you have defined direction and magnitude using this. Okay, but here if you want to define the magnitude and direction, I think you can easily do that. How can we do that? Okay, so actually the magnitude is, at the beginning I told you that if we have defined this vector, the magnitude is the value or the distance from reference to that point. Okay, from reference to that point. Okay, so what is that magnitude? What is that? What is the magnitude of this r? It is the distance between this point and the reference point. Now you are using spherical coordinate. Okay, so what is the value? Please tell me. I think you should be able to answer that. අපි දැන් මේ R ගේ magnitude එක කියලා ගත්තේ. R ගේ විශාලත්වය කියලා ගත්තේ මෙතන. Reference එකයි මෙතනයි අතර distance එක. The distance between the reference point and the position vector point. Position vector location. Okay. So what is that? මොකක්ද? That is R, no? Because here to here, that is the radius of the sphere. Okay, so in a spherical coordinate you have this R. Okay, So that is your magnitude is nothing but r. Okay, and what is the direction? Okay, so direction is the direction which we if we join this reference to that position, the direction is in this way, out of this reference point. Okay, so what is the direction? That is the r direction, no? Okay, so that is the r direction. So you have the position vector r is equal to r, that is the magnitude, and it is in r direction. Okay, so this is the unit vector. Okay, okay, so I have told you. Okay, if you have a vector, you can define it as, okay, if you divide that vector from the vector magnitude, you will get the unity vector r bar. Okay, so you can get vector by multiply the magnitude and unit vector. Okay, so magnitude is nothing but this r, here to here, that value, it's the r value, so magnitude is r. Okay, so unit vector is nothing but r dash. Okay, so I think you should be able to understand this. Okay, please think of it again and try to understand. Okay, and another important thing is, sometime we have to express this unit vector, okay, in spherical coordinate using the Cartesian coordinate also, using the z coordinate also. Okay, so unit vector we have r, and you have to define it using this z Cartesian, sorry, not z, rectangular coordinate direction. Okay, so in rectangular coordinate direction are x direction. Okay, so that is the x unit vector, y direction, and z direction. Okay, so this is the spherical coordinate. Okay, now you need to define this value in spherical coordinate using this rectangular coordinate. Okay, so how can we define it? Okay, how can we define it? Okay, I will tell you. Okay, so I am sure that you have done these things. Okay, I think in your mathematics you have done these things. Okay, I will remove this. Okay, so you have z direction, you have x direction, and you have y direction. Okay, now your point is here, r. Okay, and this here. Okay, and this is xy plane. Okay, and it's like this. Okay, and you have this value, that is 5. Okay, and you have this value, that is theta. Okay, so this is the r. Okay, and this is r unit direction. Okay, okay, I for unit vectors I use this notation. Okay, I use this cap. Okay, r cap. Okay, so r cap is the r direction, unit vector for r direction, r cap. Okay, and in the same manner I use x cap, y cap, and z cap. Okay, S cap, Y cap, and Z cap. So this S cap, Y cap, Z cap, uh, Z cap just represent the unit vector toward this direction. So the unit vector toward this direction X is X cap, this is Z cap, and this is Y cap. Okay. Okay. If you can't understand these things, don't just give up. Okay. Don't just give up the antenna subject. Okay. We need these things to identify the antenna parameter, how we define the antenna parameters. Okay. And how we can apply the mathematics concept to derive those things, to analyze those things. Okay. So don't worry. Okay. So if you are not good at mathematics, don't worry. I am also not good at mathematics very well. Okay. I also learned these things after very much effort. Okay. I understood these things after getting a big effort actually. Okay. I also couldn't understand these things at once. Okay. But now try to understand this. Okay. You can do that one. Okay. Because you have the mathematics background. Okay. As an engineer, we should have some mathematics background and we should have the ability to apply them and to do some evaluation. Okay. So you can improve that skills using this kind of things. Okay. So don't take this as a punishment. Okay. Just think this will be a beneficial for you. Okay. 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 Now you want to define this R. Okay. So now this is the Z direction. Okay. So this is the Z direction. Okay. And this is the R, no? Okay. So if you get this one, okay, if you get this one, that is the magnitude in the Z direction. So what is this value? What is this value? That is, this is R, no? R cos theta. Okay. So that is R cos theta. This value is R cos theta. Okay. So that is the magnitude of this vector. Okay. That is the magnitude of this R vector in Z direction. Okay. So if you multiply the magnitude with the unit vector of Z direction, so that is the vector in this direction, no? Okay. So I think one mic is on. I will mute it. Okay. I think it is on mistakenly, no? Do you have anything to ask? So then I will mute it. Okay. So if you have anything to ask, please unmute and ask. Okay. I think I thought it is mistakenly on. Okay. That is why I mute it. Okay. So you can unmute your mic and ask any question at any time. Okay. If you can't understand these things, you have a right to ask and try to understand. Okay. So at any time you can unmute your mic and you can talk. Okay. Okay. So this is the magnitude in the Z direction. Okay. So R cos theta is the magnitude in Z direction, and Z bar, Z cap is the unit vector. So this is the vector in Z direction. Okay. Okay. And we need to add them. Okay. Now let's see this direction. Let's get Y direction. Okay. Let's get Y direction. So this is the Y direction. Okay. No, I think it is better to get x direction. Okay, so this is x direction. Okay, this is x direction. Okay, and this is the unit vector of x. Okay, unit vector of x. Okay, and what is the magnitude? Okay, what is the magnitude here? Magnitude is nothing but this one. No, if you get this one, okay, so that is the magnitude from here to here. Okay, that is the magnitude. Okay, what is that? What is that? Can anyone tell me what is the value here? What is this value? You have to, you can give this value using r, theta, and phi. So what is the value here? You can use r, theta, and phi. This is simple r. Okay. And can you tell me what is the value here? What is this value? Okay. So if you consider this one, okay, if you consider this one, this length, this length is equal to this length cos phi, you know. Okay. So if I tell that this length is L, we don't know what is the L. Okay. So this length is L cos phi. And what is the L? Can you tell this L using r and theta? What is that? පාට හරි කියන්න පුළුවන් මේ L එක theta වලිනුයි r වලිනුයි. මේ තියෙන්නේ r, this is r, this is theta, and this is L. Okay, so you can see that Z and L perpendicular. This Z and L perpendicular. Okay, and this is r. So what is this length? What is this length? Please tell me. What is this length? Can anyone tell me what is this length? So this is r, okay, and you can see that this is Z and this direction is perpendicular. So this is r, okay. So if I write this, it is like this, okay. This is Z, okay, and this is L, okay, and you have r here, okay, and this is theta, okay. Then what is this direction? I got yeah, your answer is correct. Yeah, thank you. Yeah, okay, thank you. So that is nothing but you can see that this is r, okay, so it is r sine theta, no? So this direction is r sine theta, okay, so this direction is r sine theta, and this one is r sine theta cos phi, you know, r sine theta cos phi. So that is the x direction magnitude, okay, so that is r sine theta cos phi, okay, so that is the magnitude. And if you multiply the magnitude with the unit vector, you will get the vector in that direction, okay, so this is the direction, okay. Okay, please tell me what is the magnitude in y direction? Okay, what is the magnitude in y direction? This direction, okay. So if you consider y, okay, if you consider y, okay, so this is y, this is x, okay, and Okay, and this is you have Z. Okay, this is you have Z, and it is like this. Okay, if it is not clear, I will write it again here. Okay, this is X. Sorry, this is Z. Okay, and this is Y. Okay, and this is X. Okay, and your point is here, maybe here. Okay, maybe here. This is the R point. Okay, this is simple R. Okay, this is simple R. This is simple R. Okay, now you have like this and you have like this. This is theta, and this one is R. Yeah, I think the answer is correct. Okay, okay, theta, and this is 5. This is 5. Okay, now if you get this point to here, that is the Y magnitude, no? So what is the value here? What is the value? What is the value here? What is this value? Okay, so you have to find this value again. Okay, you have already find that. Okay, and you can see that this is X. Okay, and this is Y. Okay, and it is like this. Okay, it is like this. Okay, so this is 5. Okay, this is X. Sorry, this is Y, and this is X. Okay, and this is theta. Okay, so you have to find this direction, this value. Okay, so you have already find that value, and then you have to find this one. Okay, so this is the magnitude in Y direction. No, this is the relevant magnitude in Y direction. Okay, so what is this value? What is this? You have already find that. That is R sine theta. Okay, that is R sine theta. Then what is this value? This is R sine theta. This is theta. Okay, and this one and this one perpendicular, 90 degree. Okay, so what is this value? Please tell me. What is this value? Previously you find this value, no? That is this one, R sine theta cos theta. R sine theta cos theta. Then what is this? This Y magnitude.
R sin theta, sin theta, sin pi.
Yes, yes, thank you. Very good. Okay, that is R sine theta. R sine theta. Sorry, this is 5, no? Sorry, I'm sorry. This is 5. Okay, so your answer is correct as I draw this. Okay, but actually this is 5. Okay, don't get confused. Okay, this is 5. So it is R sine theta sine 5. Okay, not theta sine 5. Okay, so that is the Y direction amplitude. Sorry, magnitude. Then I multiply that magnitude with the unit vector, then I can get the Y direction vector. Okay, so this is the R position vector using X, Y, Z coordinate. Okay, so here is spherical measurement we write in Cartesian coordinate. Okay, so I think you have to you are going to use this frequently. Okay, later. Okay, so you need to understand this. Okay, okay, now you have to learn about spherical coordinate. Okay, sorry, cylindrical coordinate. Now, cylindrical coordinate. So, what is the cylindrical coordinate? Okay, so here you have Z X, Z Y X. Okay, and you consider a cylinder like this. Okay, you consider a cylinder like this. Okay, and using the cylinder, your point is at the position of this cylinder. Okay, your point is any. Okay, your point is here. Okay, in a cylinder. Okay, now you want to, so this is the R. Okay, now you want to find this R in cylindrical coordinate. Okay, now cylindrical coordinate. Okay, so if it is a cylinder, okay, cylinder, you can get this value. Definitely this value. Okay, so that is equal to Z. Okay, so that is we called Z. That is nothing but Z. Okay, and you have to use this value. This is the radius of the cylinder. That is rho. You can measure it as rho. Okay, so in cylinder also you need to, so this is a 3-dimension one. No? Okay, this R is a 3-dimension space. This R is in the 3-dimension space. Okay, so you need at least 3 measurement. Okay, so you can get Z measurement. Okay, so that is the height of the cylinder. Okay, and you can use also the radius of the cylinder. Okay, and you need another one more parameter measurement. Okay, so that is you get this circle, this angle. Okay, so that angle is 5. Okay, so you can uh, you can define this vector. Okay, you can define this location as R, sorry, not R, rho 5 Z. Okay, rho 5 Z. Okay, and remember that. Okay, you need to remember the sequence. Okay, rho 5 Z. Okay, and sometime you have to use the right hand rule for different purpose. Okay, so this rho related with the first finger, this 5 related with the second finger, and this Z will related with third finger. Okay, in the same manner, okay, in spherical coordinate also you need to remember the sequence. Okay, so that is, okay, this point we have defined as R theta 5. Okay, so this will be the first finger, this is second finger, and this is third finger. Okay, I will tell this, okay, later. Okay, now please remember it. Okay, 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 now this is rho 5 is it. Okay, now so I will write again this coordinate without this cylinder. Okay, so you have Z. Okay, and you have Y, you have X. Okay, and you have a position anywhere here. Okay, and that position, so this is XY plane. Okay, and that is 1. Okay, I will remove this one. Okay, so let's say that this is rho. Okay, and from here to here, that is Z. Okay, and okay, and this is 5. This is 5. This angle is 5. Okay, okay, now can you write this position vector R? Okay, so this R direction is this way, no? R direction is this way. Okay, R direction is this way. Okay, so this is the R, okay, and the R direction is this way. R direction is this way. Okay, this is the R direction. Okay, and this is the R magnitude. Okay, so can you find this magnitude and direction using this 5 row Z? Okay, that means you need to draw, the position vector, okay, using this 5 row Z. Okay, can you find that? You have to find this R value. Okay, you have to find this R, this value. Okay, and you have to find this direction. Okay, this direction. Okay, so can you try to do that one? Please try to do this by yourself. I think maybe it is possible. Please get 5 minutes and try to do by yourself. Try to think. Okay, for this R, okay, in spherical coordinate, when we write the position vector, we have to use only R, no? R and R dash. Okay, so we are not using, we haven't used this 5 and theta. Okay, the position vector we can express using R value only. Okay, and in the same manner, sometime you can define it using 1. Okay, and maybe using 2 measurement, or sometime you have to use the 3 measurement. Okay, I don't ask you to use the 3 measurement. Okay, sometime it may be enough to use only 2. It may be enough to use only 1. Okay, so you can see that, for example, here in rectangular coordinates, you have to use the 3 measurement, X, Y, and Z measurement to measure the magnitude and to measure the direction. Okay, but in spherical coordinate, only you have to measure this R value. Okay, so that you can measure the magnitude and as well as direction. Okay, and here also sometime you may need to use the both all the measurement theta 5Z, and sometime it may be enough 2, it may be enough 1. Okay, so just think, maybe if you can't actually sometime if you can't remember, maybe we can't do these things. Okay, it is hard to sometime it is hard to think in that way. Okay, ඒ විදිහට අර හිතන්න ටිකක් අමාරුයි අපිට. But if you are maths genius, sometime you may be able to. Okay, I think I also couldn't do that. Okay, maybe now I know. Okay, now I am familiar with that one. Okay, so it is come to my mind. Okay, ඒක මට දැන් හිතෙනවා. හැබැයි සමහරට මමත් මුලින්ම බැලුවා නම් සමහරට මටත් ඔක හිතෙන්නේ නැති වෙන්න පුළුවන්. ඉතින් හිතලා ගන්න බැරි වෙන්න ඉඩ තියෙනවා. Okay, so I will tell you. Okay, it will be okay. Okay, if you can't imagine it, it will be okay. Okay, because that kind of things actually we need to have good mathematics knowledge. No, not knowledge, mathematics is skill actually. Okay, but as an engineer, you should have some knowledge and you should be able to apply it. Okay, at least when someone you should be able to figure out the problems. Okay, these things I couldn't understand, then you can ask some maths expert, no? Okay, we can get the help. Okay, and also we can have some tools also now. Okay, we no need to go to a maths teacher or maths guy. Okay, but we have some tools. Okay, using that tools we can get the answer. Okay, only thing is you should know how to apply these things. Okay, okay, so here so I want to find this r magnitude, and I want to find the direction. Okay, so how to find this r? Okay, so you can see that this is rho, this is rho, okay, this is rho, okay, and this is z. Okay, so if I write these things, only this r rho z, it will look like this, no? If this is rho, this is r, and this is z. Correct? Okay. Okay. So what is the magnitude actually? Magnitude is you can use an rho and z only, no? Okay. So it is actually rho square plus z square. Okay. Rho square plus z square. Okay. So that is the magnitude. And the direction is this way. Okay. So direction is, this is rho and this is z. Okay. And you have this direction. Okay. Okay. So you can write it as, okay. So if you consider this as a vector, this is r. R magnitude is not equal to rho directly, because this is r and this is rho. Okay, so r magnitude is actually rho square plus z square root. Using Pythagoras law, you have to get that. Okay, the r magnitude is, okay, rho square plus z square root. It is not just rho. Okay, so it is a one component, no? This r is a vector and rho is this component, vertical component. Okay, sorry, horizontal component. And if this is r is a vector, this z is the vertical component. Okay, so it is rho square plus z square. Okay, so you can see that this is rho and this is z and this is r. Okay, this way. Okay, so how can you write this r? Okay, you can write this r as, this is rho in rho direction, so that is rho bar. Okay, so in this direction, this is the magnitude. Okay, so you have this rho. Okay, and this r, if you get this r into this, okay, so that is the rho value. Okay, so that is rho. Okay, rho value in rho direction. Okay, so you can write it as rho in rho direction plus, okay, and this is z, this is z in z direction. Okay, so that is z direction. Okay, so that is z bar. Okay, so you can write this as rho bar plus z bar. Okay, so in this way you can write. Okay, so I think it is clear. Okay, now if I tell you in the same manner, if we have done like as we have done in spherical case, okay, I ask you to write these measurement, rho 5 z measurement in x, y, z direction. Can you do that one? Okay. Okay. So you need to write rho 5 z. Okay. In x bar, y bar, z. Okay. So try to do this by yourself. try to find this by yourself as we have done in spherical coordinate. Okay, so try to think and try to find this by yourself. Okay, so I will stop here and I will give this as a homework to do. Okay, so this is I give as a homework. Okay, this I give you as a homework. Okay, so try to do this. Okay, you need to write this rho theta rho 5z from x dash x and y z direction. Okay, as we have done in spherical coordinate. Okay, so you have write this one. You have write the position vector using z x y direction. Okay, and here also you need to write the z position in x y z using x y z. Okay, so try to do this by yourself. Okay, and if you have any problem, I will be here around another 5 minutes. Okay, so you can ask if you have any problem. Okay, anyway, I will give the expression here. Okay, anyway, I will give the expression here. So try to realize by yourself. Okay, then I will explain it again how to get that one. Okay, so try to realize this. Okay, so the expression is like this. Okay, you have rho cos 5 x bar plus rho sin 5 y bar and z bar, because z is there, no? Z bar. Okay, so you can see that rho 5 and z you can use, and you have to use this unit vector x bar, y bar, z bar. Okay, so you need to realize this equation. Okay, so try to do this by yourself. Okay, then in the next session I will explain if needed. Okay, 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 shall we wind up? If you have any problem you can ask, or otherwise we can find up. Okay, මොනවා හරි ප්‍රශ්න තියෙනවා නම් අහන්න. If you have any question you can ask. Okay, okay, then I will leave.